section 10.1, conic sections, and we're also going to do 10.2, which is parabolas. So just as a reminder, we already talked about conic section. Conic sections is a curve formed by the intersection of a plane and a double cone. And remember, we can get the types of conic sections by changing the inclination of the plane as you make slices through each of the cones. So we have the four different graphs that we can make: circle, ellipse, parabola, and hyperbola. Now remember, we said we're only going to focus on the circle and the parabola, but you still need to know what an ellipse is and a hyperbola. So ellipses are just an elongated circle. So circle would be a perfect radius, so that would be an ellipse, or we can have ellipses that go this way. And a hyperbola is a parabola that has two different parts. So like a hyperbola, let's say this was my x-axis and y-axis, would just be a graph that looks something like this. So that would be a hyperbola, and we can also go in the y-axis as well. So a reminder that parabola is the graph of a quadratic equation. And remember that we talked about the definition. A parabola is a set of all points in the planes that are the same distance from a fixed line, which we call the directrix, and a fixed point called the focus, which is not on the line. And remember that the focus is always inside the parabola, and the directrix is always on the outside of the parabola, on the other side. And the directrix does never touch your parabola. So the standard form for a quadratic equation, if you'll recall, is y equals ax squared plus bx plus c. So the vertex form for this, we said, was y equals a times x minus h quantity squared plus k, where your vertex was h comma k. And remember, we always did the opposite of this for a vertex. So it's negative h there, but it's h comma k for your vertex. So there's two different scenarios that you have for your graphs. When your a value is greater than 0 and when your a value is less than 0. So if it's greater than 0, your parabola is going to open upwards. And remember, we said that the distance from the focus to any point on your parabola and your parabola to the directrix will always be the same. So this distance is the same as this distance. And if I even moved it to other places, so if I did this point here and then this point down here, this distance should be equal to this distance here. So that should be always the case when we're working with these parabolas. Now for this, I also know something else, that the distance from here to here is always going to be the same as the distance from here to here. So that distance we actually call our C value. So that's important because it helps us find many different things. Notice here that our focus would be up from our vertex, and also notice that the line of symmetry cuts your graph in half. So in this case, it would be x equals whatever the x-coordinate of your vertex was. Over here, when our graph is opening down, we still have this distance and this distance is the same, which is the C value. And notice that for your graph to open down, you would have to have a negative A value. So the distance from the focus to the vertex and the vertex to directrix is the same distance, which we call C. So how do we find the C value to figure out the focus and directrix? Well, your absolute value of A is equal to 1 over 4 times the absolute value of C. And you have to know which way your graph is opening in order to know if your A is going to be positive or negative. So knowing that when A is positive, it opens up, and negative opens down is important. So those graphs aren't too bad because we've done parabolas that open up or down. Now let's talk about parabolas that open left or right. So parabolas that open left or right have the equation x equals a times y minus k squared plus h. Now notice that this is different from the other one, whereas before we had y equals a times x minus h squared plus k. So notice it's different. So the vertex here is still h comma k because this h value is still an x and k still stands for y, so the vertex is still at the same point. You just have to remember when it's in this form, your h is on the outside and it's the opposite of your k value, so it's switched. Now when your a value is greater than 0, your parabola is going to open to the right, and when it's less than 0, it opens to the left. Now, notice that instead of having a directrix like we had over here, which we didn't say, but but the directrix here is going to be y equals whatever some number is, and this is y equals. So for these graphs, notice that it's a vertical directrix, so it's going to be x equals, and this would be x equals. And this distance from here to here is the same as the distance from here to here, which again we're calling our c value. How do you find the c value? The absolute value of a is equal to 1 over 4 times the absolute value of c, which is important to know. So let's go to some examples. It says, identify the vertex and the focus and directrix of the graph, then sketch the graph. So for this, the first thing that I would do is look at the equation. It's x equals. Since it's x equals, I know that my parabola is going to open to the right or to the left. Well, in this case, my a value equals -1/8. Since it's negative, I know my graph has to open to the left. Now, also for this, remember the equation, x equals a times y minus k squared plus h. Well, if there's nothing attached to the y and nothing added on the outside, then that means that my vertex is going to be at 0, 0. So in this case, I could rewrite this as x equals -1/8 times y minus 0 squared plus 0. So that means that my vertex is at 0, 0. So I got the vertex. So the next thing I like to do is sketch a graph of this because it helps me kind of determine what it's going to look like. So it's just going to be a rough sketch. We don't need to do it on graph paper. We're just going to do it over here. So I know my vertex is at 0, 0. So now that I know that, I also know that my graph is opening to the left. So now I need to figure out what my focus and what my directrix is going to be. I know my focus is always on the inside of my parabola, and it's always on the same line as what your vertex is on, so it's going to be somewhere there. And I know my directrix cannot touch my parabola, so my directrix is going to be a vertical line going this way. So x equals some number. So I need to figure out the distance from here to here and here to here in order to figure out what my focus and directrix is. Well, how do I do that? Remember that the absolute value of A is equal to 1 over 4 times the absolute value of C. So in this case, A is equal to -1/8, so the absolute value of that would be 1/8 equals 1 over 4C. So in order to solve this equation, since it has an equal sign there, we can cross multiply. So I'm going to do 4c times 1 is just 4c equals 8 times 1, which is just 8. Divide both sides by 4, and notice I get a c value of 2. So now that I know my c value, that helps me figure out my focus and directrix. So I know the distance from here to here is 2, and the distance from here to here is 2. And if my vertex is at the origin, well, then that means that my directrix is x equals 2, and my focus would be at -2, 0, because it's on the same plane as our vertex. So in this case, the directrix is then x equals 2, and it's a line, so you have to write x equals. And my focus is at -2, 0, and it's a point, so you need to write it as a point. So this would be everything they need to know. So let's go ahead and do another one. So let's look at number 1. Identify the vertex, focus, and directrix of the graph, and then sketch the graph. So for this one, this is another x equals equation. So because this is another x equals, and the reason I can tell is because the y is being squared, that hints that it's x equals. So in this case, I know that I can write x equals a times x minus h, sorry, I had y minus, I wrote x, so y minus k, quantity squared plus h. So in this case, there's nothing attached to the y, and there's nothing on the outside, so I know my vertex is actually at 0, 0. My a value is 1 over 25, and because the y is being squared, I know my graph is opening to the right. So that's the first thing I like to write down. And so if I also want to write x equals 1 over 25 times y minus 0 squared plus 0, So that gives me my original equation. So the vertex is at 0, 0. So now I'm going to draw a little sketch for myself. So if I make myself a nice little sketch, I know my graph vertex is here and it's opening to the right. And that means that my focus has to be somewhere in here. And my directrix would have to be a vertical line going this way. So how do I figure out that line? I can use my formula. The absolute value of A equals 1 over 4 times C. So in this case, A is 1 over 25 equals 1 over 4C. And then, of course, we're going to cross multiply. So 4C equals 25, because 4C times 1 is 4C, and 25 times 1 is 25. Divide that by 4, and C equals 25 over 4. So that's about 6.25, but we're going to leave it as a fraction. So now that I know that C value, distance, so that's the distance from here to here, so my focus is to the right, so I'm adding to my vertex x-coordinate 25 over 4. So this is going to be 25 over 4, comma 0, because we don't change the y-coordinate for my focus. And the directrix is now x equals, since it's on the negative side, negative 25 over 4. So now let's go ahead and look at the next one. So for this next one, x is being squared, which tells me my graph is going to open up or down. So in order to figure that out, first I need to solve for y. So I'm going to divide both sides by negative 4. So I get y equals negative 1/4 x squared. So my equation in general would be y equals a times x minus h quantity squared plus k. Notice there's nothing attached to the x and there's nothing added or subtracted on the outside. So that means, again, my vertex is going to be 0, 0. So my a value in this case is negative 1/4, which means my graph has to open down. So now that I have that, I also know the vertex is at 0, 0. And I can go ahead and sketch a graph of this. So if I sketch my graph for this one, my vertex is at 0, 0. So my graph I know is opening downward somehow. That means my focus has to be here and my directrix is going to have to be here. So to find that, I need to use my formula, the absolute value of A. So the absolute value of negative 1/4 equals 1 over 4C. So 1/4 equals 1 over 4c. So we get 4c when we cross multiply equals 4. So c is equal to a distance of 1. So the distance from here to here is 1, and the distance from here to here is 1. So then that means that my focus, we are changing the y value of my vertex because notice we're going down. So it would be 0, negative 1. So that's my focus. And that means the directrix then would be y equals, and we're going up 1, so y equals 1. So notice that when we have x equals a graph, you're changing the x coordinates for the focus and directrix. When you have y equals, you're changing the y coordinates for your directrix and focus. So just to note what I just said, notice that your x values, when it's x equals an equation, it changes the x values of your vertex for your focus and directrix. And when it's y equals, you're going to change the y values of your vertex for your directrix and focus in order to figure out what they are. So let's go ahead and do this last problem. So for this last problem, it's an x squared, which tells me that y equals something x squared is going to open up and down for my parabola. Since my a value is equal to 8, I know my graph opens up. So I'm going to write down the general equation, y equals a times x minus h squared plus k. So in this case, I know I don't have anything attached to x, so my vertex is still at 0, 0. So if I draw a little sketch for myself for this graph, I know that it's going to open upwards. So it's going to look something like this. My focus would have to be here, and my directrix would have to be somewhere down there. So then for this, if I know what my A value is, I can figure out the distance from my vertex to the focus and the vertex to directrix. So the absolute value of A, which is 8, equals 1 over 4c. So 8 equals 1 over 4c, and it's really 8 over 1. So cross multiply and you get 4c equals 8. So c is equal to 8 divided by 4, which is 2. So the distance from here to here is 2, and the distance from here to here is also 2. So notice we're going to change the y value that's on my vertex. Now we're going down to get to my directrix. So the directrix is at y equals -2, and the focus we're going up to, so we're changing the y coordinate to 2, so 0, comma 2. The x coordinate of the vertex stays the same. So that's my vertex and directrix. So let's try it a different way. Let's say we're given the vertex and focus, then we can write the equation of the parabola. So if we're given the vertex is at the origin, we have a focus of 0, 3. So I always like to write that down. So the vertex is at 0, 0, and the focus is at 0, 3. So the first thing you should do is always draw a sketch. It helps you kind of determine which way your graph is going to open. So in this case, I have the vertex is at the origin, and my focus is at 0, 3, which would be here. This tells me if this is my vertex and this is my focus. Remember that your parabola, the focus is always on the inside of it, so I know my graph has to open upwards because of that. And I know my directrix would be down here. It didn't ask me to find it, but that's what I know. So in this case, well, that helps me figure out a lot of stuff. So I know this is y equals a times x minus h quantity squared plus k. I know my h and my k for my vertex are 0, 0 because it told me that from the beginning. So that means I really only need to find what my a value is, because right now I have y equals a times x minus 0 squared plus 0, which is just y equals a x squared. So to find the a value, I need to know what the distance from here to here is on my graph, and I can even just count. If my vertex is at 0, 0 and my focus is at 0, 3, well then notice I change my y value up 3. So that means my c value is equal to 3. So if my c value is equal to 3, well then I can use the fact that I know that absolute value of a is equal to 1 over 4 times the absolute value of c, which is 3. So absolute value of 3 is just 3. So that would mean my a value would be 1 over 12. But be very careful, because I know that a has to be greater than 0 because the graph opens upwards, so that I'm going to leave this as a positive value. If my graph was opening downwards, I would have to change the a to be negative on my own. So y equals 1/12 x squared would be my equation. It didn't ask me to find the directrix, but if I wanted to write the directrix, we'll notice that this distance from here to here is also 3, so I'm going down 3. So it's y equals, because it's a horizontal line, -3 for the directrix. So let's look at this next equation that we have here. So if we want to write an equation of the parabola with the vertex at the origin, and now we're given the focus is at 0, -4. So let's draw a little sketch. So the vertex is at the origin. The focus is at 0, -4, which would be right here, which means that my graph would have to open downwards like this. So y equals, it's going to be -a times x minus h squared plus k. So I know my vertex is 0, 0, so my vertex is 0, 0, which is my h and my k. So really I have y equals -a x squared. So the distance, c, from here to here would be 4. So we went down 4. So that means that my c value is 4. So then the absolute value of a would be equal to 1 over 4 times c, which is 4. So that gives me 1 over 16. But since my graph is opening downwards, I know it has to be negative. So y equals -1 over 16 x squared would be my equation. And if I wanted to write the directrix, now notice that my directrix would be up here. and the distance from here to here has to be the same as the distance from there to from my vertex to my focus, which we said was 4. So now I'm going up 4, so my directrix would actually be at y equals 4. And I know the problem didn't ask me to find the directrix, but, since we're already doing it, we might as well help and write it out. So for the next one, we have the vertex at the origin, and the focus is at 2, 0. So again, draw yourself a little sketch. So here's my focus, and my vertex would be here. So that means if my vertex is here, my focus is to the right of that. That means my parabola has to open to the right. So since it's opening to the right, that means my a value is going to be greater than 0. And that also means my directrix would be here. So the distance from here to here, we're changing our x value. So from 0, 0 to 2, 0, and that means my c value would be equal to a distance of 2. So to find my a value, a is equal to 1 over 4 times 2, so a would be equal to 1 over 8, and I know it's greater than 0, so it's going to be positive. Since my graph's opening to the right, it's x equals equation, so x equals a times y minus k squared plus h now, and we said our vertex is 0, 0, so this is still h and k, so really it's x equals a y squared. And we just said our a value was equal to 1/8. So this would be the equation. And if I want to find the equation for the directrix is now x equals, and the distance from here to here would be 2. So x equals -2 because we're going to the negative side of our graph. So x equals -2. So let's go ahead and do this last one. So for this last one, the focus is at 1, 0, and the vertex is at the origin. So -1, 0 would be here. The vertex is here, so that means my graph has to open to the left. So if my graph is opening to the left, that means my a value is less than 0. So x equals -a times y minus k squared plus h. So in this case, x equals -a y squared because my vertex is at 0, 0. So that's my h and my k. So then for this, I need to figure out the distance from here to here. So if my focus is at -1, 0, that distance of c would be equal to 1. So a is equal to 1 over 4 times c, which is 1. So a is equal to 1/4. And because it's opening to the left, it has to be negative. So x equals -1/4 y squared would be my equation. My directrix would be on the other side. So my directrix would be right here. And I know the distance from here to here is also 1. So x equals 1 because it's on the positive side. Now, there's some more formulas that we need to talk about, distance and midpoint formulas. Now, recall that if we wanted to find, if we had a right triangle, and let's say this was A, B, and C, and we wanted to solve for one of the sides, we use Pythagorean Theorem, which states that a squared plus b squared equals c squared. Well, let's say that we're not given very nice values, and we just have these points that we have to use. Well, for this, I know that the distance from here to here is going to be the absolute value of, and this point right here I didn't write down, is x2 comma y1. So the distance from here to here would be your x2 minus x1, and distance is always positive, that's why I put the absolute value there. The distance from here to here, you're going to subtract your y values, so that distance would be the absolute value of y2 minus y1. And if I wanted to find this length, well, I can use my Pythagorean theorem to figure that out. So I know that d squared would be equal to this length squared and this length squared, and then I can take the square root of that. So the distance formula that we actually use is d is equal to the square root of x2 minus x1 squared plus, and that takes, the square takes care of the fact that it has to be positive distance, and then y2 minus y1 squared would be my distance formula. We also have a midpoint formula. So the midpoint formula, the way that you write it is, how do you find the midpoint of something? You take the two numbers and add them together and divide by 2. So that would be the x-coordinate. The y-coordinate then would be y1 plus y2 over 2 to find the midpoint. So make sure that you know those two formulas there. So those two formulas are helpful because it allows us to do the next problem. And we're actually going to do the next problem in class together. So just hold off on this one. We'll do it together. But make sure you have the rest of this with you in class.